In section 6.2, what we'll talk about now is looking at normal distributions that do not have z-values yet. So, we still want to find probabilities, areas, and percentages for these normal distributions, either to the left, to the right, or in between two values. But this time we don't have z-values. So it's going to be a tiny bit different, not a huge deal though. So this first example is a perfect place to start. We've got IQ scores are normally distributed with a mean of 100. Now when we had z-values, the mean was always 0 and it went in the middle. Well, mean still goes in the middle even though it's not 0. The mean is mu, which is 100. So we'll put that in the center. And our standard deviation is 16. Find the percentage of people's scores, of IQ scores greater than 115. So that's what they're asking for, is about that we want scores to be greater than 115. What's the probability or percentage? Well, 115 is a little bit bigger than 100, so it's over here. And because they say greater than, they're telling us that they want the area to the right of 115. Scores that are bigger, greater than 115 are to the right. So they're talking about us finding this area on the right-hand side. Now, in the last section, we did something just like this using a normal CDF. We're going to do the same thing, but we'll have to give the calculator a little bit more information because we don't have z-values. Now, or you can take your 115 that we have here and turn it into a z-value using the formula we used back in chapter 3, back for test 1. You can use this formula. Remember that this formula says to take your value, whatever it is, subtract the mean, and divide by the standard deviation. And then you would just have this value as a z-value. And then you could use your normal CDF the exact way we did before if you convert it to a z-value first. However, why do that when the calculator will go ahead and do the conversion for us? So how does the calculator do that? Well, it takes the two pieces of information that we need in the formula, the mean and the standard deviation. So it takes the standard deviation and the mean and does this calculation behind the scenes for us. So it'll do this entire calculation, turn our value into a z-value, and then find the area of probability for us. So it's going to be very similar to what we were doing before back in 6.1. We'll still do exactly what we did, which was we press the second key, then press the vars or distribution key. We're still going to arrow down and do the normal CDF, just like before. The only difference is that we're going to give it a tiny bit more information, not less. So I'm going to recopy my graph I've got here, which had my mean, which was 100 in the middle. And remember, I'm going to write down what my standard deviation is because I'll need that. Was 16. It was given in the problem. And then also in the problem, they said we were looking for 115 and wanted everything to be greater than that. So this was the picture I was looking at. Okay, so how is our normal CDF going to be different for this section? Well, what'll happen now when we go to do our normal CDF is it will start out the same way. You'll still have your start value, which working from left to right will still be your 115, comma, you're still going to go off towards infinity on the right-hand side. Going to keep on going over forever and ever. And remember, we used a positive 10 to the 99th when that happened. Still the same. So at this point, nothing else is different. But because we do not have a z-value, that 115 is just an ordinary mean, not a z-value, we have to give it two extra pieces of information. The first thing that we have to give it is always the mean, which according to this problem, our mean was 100. So we'll give it that piece of information first. Comma, then the second piece of information they want is our standard deviation, which was 16. And that will go in last. And we'll have our calculator calculate it, and what we can see is the value that we get out of our calculator when rounded is 0.1743. That's our probability or area. However, on this particular example, they wanted us to give a percentage. So then I'd still have to take this probability and turn it into a percentage by multiplying by 100. And that would turn this into 17.43%. So